Okay, taking a look at part C. Part C, which you'll have on your paper, asks what time between 0 and 8 is the amount of water in the pipe at a minimum. Okay, again, most of these problems, if you try to think about the scenario before you try to think about the basic concepts, you're going to psych yourself out. Okay, so remember what we're looking for here. Maximum and minimum values of functions in general. We're talking about the function that's the amount of water in the pipe. Maximums and minimums happen either when the derivative is 0, relative minimums and maximums, or they happen at the endpoints of the interval. So we've got some function, we don't even know what the function is, but we've got this total amount of water function, which has something to do with the integral of the rates. But we're not even going to mess with that. So the point here is we need to figure out how much water was in the pipe at the endpoints. How much water was in the pipe at t equals 0, how much water was in the pipe at t equals 8, and if there are any places where the derivative is 0, we need to figure out where those are too. So 0 and 8, that'll be pretty easy to check. But we need to check the amount at any relative minimums or maximums as well. Okay, remember that the relative minimum or maximum happens when the derivative is 0. Remember, another word for derivative is rate. We want to figure out where the rate of change is 0. So imagine, if you remember, when you found the rate of change of the water when t was equal to 3 hours, the water was dropping, okay? But let's say that the water's dropping, that rate's negative. Let's say that the water starts rising. What rate does it have to pass through when it hits a minimum and then starts going up to a maximum? It's negative rate, negative rate, negative rate, then positive rate. It's got to pass through a 0 rate, okay? So we need to figure out where the overall rate of change is equal to 0, okay? Well, remember, this is the rate at which it comes in. That's the rate at which it goes out. So we just need the rate at which it comes in minus the rate at which it goes out to be equal to 0. We just need to solve that equation. Okay, and remember, this is a calculator problem. This would be brutally difficult if you didn't have a calculator. But you can take this 20 sine of t squared over 35 equation, and you can subtract this d equation here, and use the 0 function on your calculator to figure out where that occurs. Okay, now in this particular problem, I'm just going to go ahead and take a look at where that occurs to save a little bit of time here. Turns out you can see here they're checking the endpoints, how much water is at the start, how much water is there at the end, at the 8th hour. 3.271568 hours is the time when the overall rate's equal to 0. That's the point at which, actually, you could set the rate in equal to the rate out. Okay, the water's leaving exactly as fast as it's coming in, and you could solve that as well. Anyways, they're going to check those 3 points. Now, they told us that there were 30 total cubic feet of water in the tank at the start. Okay, so we have our amount of water. Okay, we just need the lowest overall amount. It's got to happen at an endpoint or a relative min or maximum. Okay, so we've got that 3.271 point, and then we've got 8. Okay, remember, we just need to find the rate, the overall rate of water coming into the tank over that 8-hour time period. Well, actually, of the time period up from hour 0 to hour 3.271. So remember, this is the rate of change, okay? We can take the integral of the rate of change, okay, and these are both rates, and we can take that integral from our starting time of 0 to our ending time of 3.271. Okay, and again, you'd probably put those 2 equations in and you'd run those numbers. But remember, that's just how much water comes in those first 3.27 hours. You've got to add that to the initial 30 cubic feet of water that were coming in. Okay, and you can see here the answer says that it's going to be about 27.965 cubic feet of water. Okay, and then we've got to check at the end. You know, maybe our lowest amount of water happens at the end. Well, basically, it's just the same thing. Here's the rate of change, but we want to figure out how much water comes in between time equals 0 and time equals 8. And so you can take that integral, and then you can add 30 to that, and you end up with about 48.54. So notice the lowest one here is 27. That's your overall minimum value. All right? So not too terrible, although it does take some time.